Hello there. Good morning, good afternoon, and good evening from wherever you're joining us today. We want you to know that we have here a crowd from over 50 different countries. My name is Shai Alon. I'm a startup evangelist here at Google Cloud, and I'm really excited to be here with you as the host of today's session. The session is Deploy Your Agents with Confidence, Hosting, Scaling, and Best Practices. Alvin will talk about the essential strategies for deploying, hosting, and using your intelligent agents effectively and managing and scaling them in real world deployments. We'll explore key hosting philosophies covering the balance between control, ease of use, and cost considerations. Now, before that, let's see where we are with the school's curriculum. So this is quite easy. We're at the very last session for Startup School Agentic AI for the APAC region. So at week 0, we have these sessions on demand. Week one, where you learned how to build intelligent agents. Week 2, where we went more in about the agent engines and their potential. And week 3, we had an amazing session with the Datadog about LLM application. So again, this is the very last session, and it's run live here. Each week we host these live sessions, and you can and do have labs and notebooks for you for the various sessions that we already had. In this Cloud Skills Boost platform, you can also obtain specific skills badges. And again, the sessions that we already had are available on demand. Speaking of Cloud Skills Boost, to be able to access these labs free of charge, you will need to fuel your account with credits on the Cloud Skills Boost platform. All the information you see on the slide was provided in either a reminder email or a confirmation email that you all received. So if you haven't seen it, please, pretty please, double check your spam folder for emails coming from googlecloud@google.com. In just about 100% of the cases, it turns out that the email was there. But just in case you still have some troubles, please send us an email at startupschool-external@google.com. Gabby and the rest of the team are here to help you. So before we jump into today's class, a few housekeeping rules, and these will just take a second. So as you can see on your screen now, there's a chat function on the right-hand side and a Q&A panel at the bottom. We have Google AI experts on hand to answer any questions that come up throughout the class. So please ask your agentic AI specific questions in the Q&A panel below and interact with other founders and developers in the chat. And one more request, please refrain and avoid from sharing your LinkedIn profiles in the chat space. We are going to be saving the last 10 minutes of class for live Q&A with our instructors, and we'll select the most common questions asked and those relating directly to the content. So please upvote questions in the Q&A panel and use the chat space to converse with other participants. We are recording each class, and you'll be able to watch it back on demand at a later time. And you can access these recordings via the main program page. One thing to note, we won't be sharing slides, but we will share links to the labs covered in the class, both during the class and in the chat Q&A panel, and also in our weekly recap emails. You can also find the list on the resources tab on our website. And last but not least, this is a hands-on training series, and most classes will cover a lab. So all of these are available on the Cloud Skills Boost platform or on our Google Cloud GitHub repo. We'll share all the links with you to access both of these We recommend using the time during the class to watch our instructors and going through the lab and completing it after the session. The credits we provided will last you for a few months, so you have plenty of time. And that's it for me. Now it's a big pleasure for me to invite to the virtual stage our amazing speaker, Daniel Prayuda, a developer advocate at the APAC region for Google Cloud. Welcome to the Startup School stage. I will see you later for the Q&A. And until then, the floor is yours. Good luck and have fun.
Okay, thank you, Sai. Hello, everyone. So before we start, maybe I'll introduce myself. My name is Alvin Prayuda, and I'm a developer advocate here in Google Cloud for the APAC region. So once more, welcome to today's session on deploying your agents with confidence, hosting, scaling, and best practices. And I'm really, really excited to share some insights with you today, where our most focus will be about the practicalities and strategies for deploying your AI agents. So the journey of building an AI agent, whether it's a chatbot or maybe a complex automation tool or an intelligent assistant, often starts with excitement and innovation. We are trying to try different prompts engineering strategies, trying to craft our prompt so that it can produce spectacular result, fine-tune our models, and get our agent working perfectly on our local development environment, usually. But then comes the moment of truth when we are trying to deploy our agent. And that's where sometimes the confidence can waver, right? Because we are facing with real users. How do we take that brilliant agent from our machine to a scalable, reliable, and production-ready environment? That's the core dilemma we'll be addressing today. How to move them from, ooh, it works on my PC or on my laptop, to, okay, it's confidently serving users globally. And for the first subject, let's kick off with this section, trying to understand the very nature of agent deployment. So what exactly is the problem we face when trying to put our AI agents into production? So to put this simply, what are the primary challenges that arise when we talk about deploying AI agents? It's, of course, it's not just about getting the code to run somewhere. It's much more nuanced than that. So often when we are in the development phase, our attention is heavily skewed towards certain aspects. We are innovating, we are experimenting, and making sure that the agent does what it's supposed to do, at least on our workspace, right? So this is what I call the development focus. It's kind of similar, like every application development. AI agent development also have different focus when we are talking about development versus deployment environment. And it might be more complex. So typical application development might encounter issues like maybe local versus cloud database access, maybe unconstrained resource on local versus constrained resource on cloud, access control, and many other things. Now, if we are talking about AI agent, it will definitely involve more. Now, let's see what other things affecting the agent development focus. So this is what it looks like from my perspective. Specifically, our development efforts typically concentrated on things like, first, of course, the agent functionality. Does the agent answer correctly? Does it perform the sequence of desired actions? Does it execute the right tool? And does it perform consistently? This is when we are trying to play with our prompt, with our code, and, and, and ensuring that the result is correct. And related to this, of course, we are trying to do some prompt engineering, crafting the perfect prompts to get the best responses from our large language models. And after that, we are trying to think. We already designed the prompt, but it looks complex, it looks complicated. Will it support our business logic? Will it support our design flow of the agent? Should we use a workflow? Should we use the single agent with complex prompt? Or maybe should we decouple it to multi-agent? So here comes the decision of the agent architecture. And then related to the AI agent, it comes the matter of how we handle the data access to the agent, the data handling. We have several options, like we might develop our own tools to interact with database, to interact with some cache server, and we might consider using model context protocol, MCP, or maybe we can just using any external tools there to access the database of API. And then it comes the evaluations part. After we design all of those things, we need to rigorously testing the agent's performance and accuracy. And then maybe we can come closer to the deployment perspective in here. How can we manage the context? Do our agent need to need some context from previous turn of conversation? So we need also think to ensure the agent remembers previous interactions and maintains a coherent conversation. And related to managing context, also a fundamental design choice, whether our agent will be stateful or stateless. So these are all crucial during development. Right? It's so many things to be considered about, and yeah, we need that, and because they define the agent's core capabilities. However, when we shift our mindset from its previously development and now it's time to deploy, a whole new set of considerations comes into play. So these are what I call the deployment demands, and they often don't receive enough attention early on. Beyond our development focus, suddenly we need to think about robustness. Can the agent handle unexpected inputs? Can the agent recover from failures gracefully? And then we also need to think about data access. We already considered the data handling previously in the development focus. Now we need to ensure that the agent can access the data securely. Will we require a private connection to access the database? Will it can be efficiently access the data it needs, and things like that. And then the next section is about the maintainability. How easy is it to update, to patch, to debug the agent in production, right? So we, of course, don't want to play fire when we are fixing something in production and directly change the code in production and serve it to our users. So that's a poor maintainability. And then we also need to think about security. For who's this agent intended for? Is it available for our user, or is it available for only a subset of user? We suddenly need to think about protecting user data, preventing unauthorized access, and securing the API keys. And apart from that, we also need to think about integrations. How will the agent connect with other systems? Can it connect directly with the front end, maybe, or maybe can it connect directly with the other services, the other APIs? And the most critically is the scalability. Can the agent handle a sudden surge in user traffic without failing over? These deployment aspects are what often separate a successful prototype from a robust production-grade AI agent. And when it didn't handle properly, this what I illustrated will happen. It burns everywhere. So this slide illustrates a classic dilemma in software development, but amplified when dealing with AI agent. But it works on my machine. We've all been there, maybe, yeah? Your agent is flawless in your local environment. Maybe it can generate a very, very good SQL. Maybe it can correctly retrieve all good information. But when you push it into production, suddenly your stakeholders are all throwing errors to you. Errors are everywhere. Maybe some of them asking about, I tried to talk to the agent, but it never responds. What happens? Or maybe this is a personal case I've been experiencing before. Why this bot doesn't remember our previous discussion? Are you sure you have the correct system prompt? Can we check it together? And maybe from the other case, also having a case like this. My team is trying to deploy agent together, but somehow two of the members receive response, but the three others doesn't receive any response. When it takes so long for the agent to answer. So this happens because of the protection environment introduce complexities like networking, security, scaling, and resource management that are simply not present or not fully simulated on a single development machine. So overcoming this gap is what building confidence in deployment is all about. And next, we will see how do we navigate this complex landscape. When designing our deployment strategy, commonly there are three primary factors that we need to consider and often prioritize. So I call it the simplicity, cost, and control. So it's pretty rare, I think, to get all three perfectly balanced. Hence, understanding which ones are most critical for your specific use case is really the key. So let's walk this one by one. The first one, let's discuss simplicity. When we talk about simplicity, these are some of the example of cases that we should consider. The first one is ease of deployment. Can you get your agent up and running quickly, maybe with minimal configuration? And after that, can your engineer easily learn how to deploy service on top of it? So those are the example of the consideration when you are choosing a platform with ease deployment. And then after that, do the platform have our needed production standards? Do they have already built-in features for that? Maybe the platform provides sensible things like logging, monitoring, or security. If yes, maybe you also need to consider if I want additional functionalities, is it easily embedded in there? Or maybe if it can, oh, it's just enough for starter with the logging, monitoring, and security. So the idea here is to reduce the cognitive load, the operational overhead, and the learning curve, especially in the early stages of teams with limited DevOps experience. And the next is cost. And by the cost, I don't just mean the bill of your cloud provider, but I mean the total cost of ownership, which includes human effort in there, of course. So what kind of effort that we need to consider in here is the first one is the learning curve. How much time and effort will your team need to invest, to learn, and master the deployment platform? And then after they can do it, how much time required for prototype access? Can you quickly deploy a prototype to get feedback or maybe iterate faster? Of course, this also impacts the time to market, right? And then how easily we can maintain, update, and sunset, because the ongoing operational cost will associate it with keeping the agent running, applying updates, and eventually, if it doesn't need it anymore, decommissioning it. So this effort translates directly into engineering hours, which of course translates to real cost, right? And finally, it's about control. This is about how much granular control power you want to have over your deployment environment. So do you need to specify exact CPU, exact number of instances, exact memory type, or maybe exact GPU type for your services? Do you really need those fine-grained resource control? Or maybe you can have it trade-off without only important resource that you can control. And then the next example is, do you require specific strategies for deployment, like maybe controlling any network? You want to do maybe canary releases, or maybe blue or green deployments, or custom scaling policies? And the last thing is, do your service need a very specific hardware requirements, perhaps for highly specialized models or maybe specific accelerators? Things that needs to be noted that greater control often comes with increased complexity and potentially higher cost, but maybe it's essential for highly specialized or performance critical application. So let's summarize our deployment factors we previously discussed. So the first, for simplicity, maybe we need to consider ease of deployment, built-in production standards, maybe minimum features needed to run our agent, and how well it aligns with your team's existing expertise. And for cost, think about the learning curve, the time to market, and the ongoing effort for maintenance and updates. And last, for control, evaluate if you really need more fine-grained resource control or maybe custom strategies or specific hardware. So these factors will guide our discussion today for your AI agent deployments. We'll specifically dive into a service that helps address these challenges effectively. But before that, I want us to take a look to this architecture. So this is a high-level architectural overview for deploying AI agents. And as you can see from the diagram, it's not just about the agent itself, but an ecosystem of services working together. On the left, we have the user interacting with front end, and then the front end will then connect to the deployment we are talking about right now, the deployment layer, which it could be something like Vertex AI agent engine, or maybe a custom API server deployed in the Cloud Run, the GKE, or maybe your own virtual machine. So this is where our agent code lives and serves requests. And the deployed agent itself then interacts with the LLM orchestration layer. So this is a frameworks like Google ADK, LangChain, or maybe Crew AI comes into play, managing the complex interactions with large language models. The LLM orchestration layer relies on LLMs themselves, such as Gemini or maybe via Vertex AI Model Garden. And usually, we want our AI agent also have some grounded truth, right? So they need to access some data. Our agent might utilize a vector store maybe for embeddings and traditional data storage and analysis, like maybe Cloud SQL or BigQuery. And crucially, we also need to understand how our agent behave in production. Definitely, we will need observability, which may include cloud logging and distributed tracing with CloudTrace or maybe OpenTelemetry. And this also can be fed into monitoring solutions like Looker Studio. And underpinning all of this, maybe help you to orchestrate all things needed for this, we might need to utilize infrastructure as a code, maybe using tools like Terraform and continuous integration, continuous delivery, manage their services like Cloud Build. So this diagram highlights that a robust AI agent deployment is not only the deployment, but it is a system level challenge requiring thoughtful integration of various components. And you can do all of this in Google Cloud. Okay, now let's pivot and talk about a specific powerful solution that helps simplify many of these deployment challenges, the Cloud Run. So this is the second major section of our talk. We'll be focusing on how Cloud Run provides effortless deployment on scalable infrastructure. So what exactly is Cloud Run? In a nutshell, it's a fully managed platform that allows you to run your stateless containers quickly and securely, built on top of Google's incredibly scalable infrastructure. It brings together the flexibility of containers, meaning you can package almost any application, any language, with the simplicity of a serverless experience. So this combination is designed specifically to boost developer productivity by abstracting away the underlying infrastructure management. When we talk about serverless benefits with Cloud Run, we need to understand that serverless is far more than just a functions. It's a fundamental shift in how we think about deployment. So rather than only a function, we've evolved to a single uniform serverless platform that supports many spectrums of abstraction, from individual functions to a full-fledged applications and even custom containers if you want to. So one of the important feature in here is you can control per instance concurrency, meaning a single deployed instance of your agent can handle multiple concurrent requests, dramatically improving performance and efficiency. And definitely you can also control the concurrency level. We will see this further in the demo later on. And Cloud Run truly offers a very flexible possibility. You have the freedom to use any programming language, any library, and any framework you desire. So this broad compatibility ensures you don't have to rewrite your agent just to deploy it, in which it also leverages open technologies, open protocols, and integrates seamlessly with popular build tooling. And one of the most important thing, if somehow in the future you think that your deployed service on the Cloud Run is not sufficient, you want more customization, the deployed service on the Cloud Run is very portable and interoperable with Google Kubernetes Engine, the GKE. So as your needs evolve, you have a clear path to move to more granular control if required without being locked in. And within the Cloud Run itself, there are two primary resource types, which each suited for different use cases for your AI agent. The first one is a very common one. These are designed to serve HTTP traffic. We call it services. If your AI agent is a chatbot, maybe with a web front end or an API endpoint, or needs to respond to events like webhooks, then Cloud Run service is what you'll use. They provide an out-of-the-box URL with TLS, automatic scaling for both minimum and maximum, and built-in traffic splitting for various deployment strategies. And in contrast, when we are talking about jobs are for executing tasks to completion. So they don't have an HTTP endpoint, and we might think that these jobs is kind of batch processing use cases, data cleansing, or maybe schedule run for specific tasks. And this job can be executed manually or on a schedule, and they scale automatically based on the number of tasks you specify, running for various duration that which you can control. So understanding this distinction is crucial for choosing the right deployment model for different parts of your AI agent solution. And for the options itself on how to deploy your agent, Cloud Run offers flexibility in how you want to actually deploy your agent code. So the most versatile option is using the container. You can maybe deploy any OCI compliant container image. This means that if you already have a container or a containers image of your agent using Docker, you can simply push that image to a supported repository like Artifact Registry or maybe Docker Hub, and Cloud Run can deploy it directly. This provides maximum portability and control over your environment. And of course, for quicker deployments, you can choose to deploy from source code or maybe from function. So if you are using a source code, the Cloud Run will automatically build a container image for you, and it supports a wide range of popular languages like Python, Node.js, Go, and several other else. And this option is great for rapid iteration, as you don't necessarily need to manage Docker files by yourself initially. But of course, if you want to provide it, you can do that too. Okay. Now, I think it's kind of enough for the theory. I hope several of you doesn't really feel sleepy hearing all of this. So let's try to see some demos and some practicality in actions. Okay. Okay, so the first one, let's walk through a video demonstration. And this is the first demo showing how to take an agent development kit or ADK-based agent and deploy it to CloudRun directly from the command line interface. And this demo will highlight the simplicity of the gcloudrun deploy command and how quickly an agent can be made accessible. All right, let's kick off our demos by showcasing a more realistic AI agent deployment on Google CloudRun. So this isn't just a Hello World agent. It's designed to be a bit more robust and interactive. And currently, I'm using my Cloud Shell editor. And here in my project directory, we have a few Q files on how to do this. Let's inspect it one by one to understand more about what we want to deploy. So first, we have this weather agent. And under the weather agent directory, we have our agent.py. So this is where our actual AI agent logic resides. Notice that it's an ADK agent and it's configured to use the Gemini 2.5 Flash model. And crucially, it includes a custom tool called getWeather. And this tool, which you can see defined here, simulates how it can fetch the weather information for specific cities. Currently, it's a mock function and only support the New York, London, and Tokyo. And we've even added some basic logging with the tool for observability. But yeah, it's a mock tools. But I think in this demo, it is sufficient to highlight the agent capabilities that we want to deploy. And next, we have our main script, server.py in this working directory. And this is a fast API application that acts as the entry point for our agent. So it uses the GetFast API app in here. This GetFast API app helper from the ADK help us to expose our weather agent as a web service. Of course, you folks can modify this to use your own customized fast API route if you want to. But this definitely help us quickly deploy our agent as a fast API app. Now, a key point here for this agent to maintain context across multiple user requests, and even if it scales to many instances, it needs a session service. So when you are prototyping, usually you'll use in-memory session service, right, for simplicity. But in this demo, we want to make it closer to production deployment setting. Hence, we've already prepared a Cloud SQL PostgreSQL database, this one. So this database will serve the purpose to store the conversation context, conversation state, and so on, which will be utilized by the session service. And yep, let's get back to here. You can see we configured this setting by maintaining the session URI environment variable, this one. So if it's provided, our agent will use that external database for session management. This ensures state is preserved even if the service is restarted or maybe disruptions happen, which is of course critical for continuous conversations. And other than that, we also configure some tracing in here, but we will we will explore this in a later demo. And finally, we have our Docker file. This defines precisely how our application is packaged into a container image. So it's a standard Python Slim image, copies our code into the app directory, installs dependencies, exposes port 8080 in this case, where our fast API server will listen, and specifies the command to run our main server page application. So this setup with our own server-py backend script and this custom Docker file showcase the degree of freedom you have on Cloud Run. So unlike simple serverless functions, Cloud Run allows you to deploy virtually any containerized application, giving you full control over your environment and dependencies, which is perfect for complex AI agents. Okay, and now for the deployment. So this isn't just a simple service. We will need to connect it to PostgreSQL database hosted on CloudSQL, and our deployment command will reflect this added complexity. So let's see our deployment command. So our deployment command will be this one. And let's break down this command and its flags for now. So we have a gcloud run deploy weather agent. So our service name will be named a weather agent in here, and it will deploy and build our container image directly from our current directory using the Docker file we just saw. And we also tell the Cloud Run that our application inside the container is listening on port 8080, matching our fast API server py. And standard configuration, we specify the project and the region for our Cloud Run services. And for the sake of this demo, for this tutorial, we allow the unauthenticated access. It will be publicly accessible for your service from anywhere. And the next settings is I think the most critical one. Is because we will need connection to Cloud SQL instances. We will use the flag add Cloud SQL instances. So this flag will automatically set up a secure private network connection from our Cloud Run service to our specified Cloud SQL instances. Our agent can then access the database as if it were local without exposing it to the public internet. And those are the settings for the connection of our Cloud Run services. Now we will also need to configure the environment variables for our application. We will pass the environment variable session service URI to our agent. And this URI will use the Cloud SQL proxies Unix socket to connect our PostgreSQL database, instructing the ADK to use this database for managing user sessions. And we also set the Google Cloud project as well for the Gemini API. And I think it's important to be noted in here that putting this database URI on environment variables is not the best practice because it's more secure. It will be more secure to put this kind of information as a secret. And the last thing here, the minimum one, is ensures that at least one instance of our agent is always running. So this will avoid the cold start delays, meaning our agent will respond instantly without needing to wait the service to be spun back on, even if it hasn't received any traffic for a while, which is great for user experience. All right. And this is how we can execute it. After you run the command, you will see some logs shown on the terminal. It will build the Docker file and store it in the artifact registry. It will set up some IAM policy. It will help you routing traffic in here. And after it's all finished, you will see the public URL of the cloud services shown to you in the log. And then we can try to interact with it. So for example, if we go to if we go to here, we will see our agent already deployed. And then we can check like, hi, hello, how can I help you today? What is the weather on Tokyo? And yeah, it already can answer to our query. And after we finish deploy our agent, we can see the details on the Cloud Run console. For example, in here, you will see that your agent is already deployed. And when you click the agent, it will show all the details needed for you to inspect the agent. The public URL, the region, the configurations in the YAML files, and then the logs, and all of things is shown in here. Okay, fantastic. And that's how you can quickly deploy your agent to the Cloud Run. Oh, sorry, I forgot to unmute it. Okay, so that's how we can deploy our agent to Cloud Run quickly, but still have degree of customization on the backend and Docker file itself. Then it will provide you all things needed about the public URL to access the service, system diagnostic dashboard, and other configuration that you can control for full information and manageability of your services. So now you already have your agent deployed. The next question is how we can test its reliability. So following the initial deployment, the second demo would showcase on CloudRun's auto-scaling capabilities. So I would like to show you on how to do a load testing and see the auto-scaling feature in action. This will illustrate how you can ensure your agent to scales efficiently to handle varying loads without any manual intervention. Okay, now our weather agent is already deployed. So our next demo is to observe our agent auto-scaling behavior on Cloud Run. But first, we will going to deploy a new revision of our agent, but this time we'll explicitly limit the concurrency. That is the number of simultaneous requests a single instance can handle to just 10. So this will help us clearly observe Cloud Run's auto-scaling in action when we put it under load. So here's the gcloud command we'll use. And notice that we set the concurrency flag here to 10. The other flags are familiar from our previous initial deployment. So let's just execute this in here. And I need to update my project ID and enter it. All right. So likewise, this deployment will take a moment, and let's wait it and check whether the service is ready to serve some traffic when it finished. Okay, now that our agent revision with new concurrency limitation is already deployed, how do we observe the auto scaling? We need to generate some load, of course. I have a simple Python script in here called loadtest.py, this one, and it used the popular Locust library, which is a popular framework to load testing in Python. And this script is designed to simulate multiple concurrent users interacting with our chat agent backend. So you can see in here, we configure the endpoint to be hit is the run SSE endpoint, which is the streaming endpoint of our agent. And it also handles creating new sessions, mimicking a more realistic multi-turn conversation from the users. And to run this load test, we will use the locust command and point it to our deployed Cloud Run service URL. So let's just run it. Let's copy this command, paste it in here. I need to change the Cloud Run service URL to our service URL. Supposed to be this one. And then let's paste it in here. Okay, now the test is already running. So this load test will run for 1 minute. We need to wait for a little while. And during this time, it will spawn the number of users up to 60 users with the ramp up rate of 5 users per second. This will quickly put significant pressures on our agent, forcing Cloud Run to scale up instances. And while this is running, let's wait for a little while until it finishes. Okay, now the test is already finished. And then let's check out our weather agent service details and see whether it scale up as intended. So let's back for a little bit and then go to the service details again. So in this dashboard, you will see a various metrics. So let's look closely on the instance count graph, this one. Zoom it a little bit. Oh, sorry. So it's supposed to be this one. Okay, so see how the number of instances quickly ramps up? This is Cloud Run automatically scaling out to handle the incoming traffic from our load test. It's reacting directly to the increased request load. As requests come in and as each instance approaches its limit of the concurrent request, Cloud Run will provision new instances to maintain responsiveness and prevent bottlenecks. This visual confirmation is powerful for understanding and validating your auto-scaling strategy. And even when the traffic is stop coming, the Cloud Run still maintaining the active instances. And when the traffic already stopped for a little while, it will try to decrease the idle services and to use the most efficient resources needed. So thank you for attending this demo. Okay, so yeah, I hope that demo can showcase a little bit on how Cloud Run auto-scaling's behavior. We try to limit our concurrency. We put it to some load tests. And then, yep, I think we can see a clear picture in there, how it scales and how it downscales when there are no traffic occurs. And for the next one, maybe we'll talk about traffic management, which is one of the Cloud Run important features too. And it's a critical aspect for safe deployments. So in this demo, I would like to illustrate the Cloud Run's built-in traffic splitting, which allows you to deploy new versions of your agent alongside existing ones and gradually shift traffic to the new version, enabling a deployment scenario such as a canary deployment. So this significantly reduces the risk associated with new releases. Now, one of the biggest concerns with deploying new versions of any application, especially an AI agent, is the risk of introducing bugs, or in a more specialized agent case, unexpected behavior after prompt updates maybe. So Cloud Run provides powerful traffic management features that enable safe, gradual rollouts, easily manipulate percentage of traffic coming to specific provisions, allowing you to deploy with confidence. So now let's simulate a new version of our agent. So for example, in here, I will make a tiny prompt update, reject any conversation that isn't related to weather information. Yeah, things like this. Okay. Now I'll try to deploy this new version using the same gcloud run deploy command. It will deploy to our previous deployment name, the weather agent. However, this time I will add this no traffic flag. This flag will make any subsequent revision deployment will have 0% traffic directed to it. Okay, so now let's try to deploy it and wait until it finishes the deployment. Okay, let's put it in here, and then let's execute it. This will take a while until it finishes the deployment, and we will see in the log that the new deployed revisions will serve 0% traffic. Okay, we can now see that a new revision is already deployed. This one, it's revision number 00082CB, and it's serving 0% of traffic. Now, let's go to the Cloud Run service details to see how to modify this value. So this is the Cloud Run consoles, and we click on the weather agent details. And then let's go to the revisions. Okay. Oh, it's not refreshed yet. So maybe let's try to reload it again. Okay. Now it's appearing here, the new revisions. Okay. Now, notice that our previous revisions still receiving 100% of traffic, while the new revision is at 0%. So this is crucial. This means that our users are unaffected by the new deployment initially. So we can easily modify the percentage of this traffic from this console. So click on the actions and then click manage traffic. So let's modify the new revision traffic to 20% in here. And you will see that the latest revision, the number 7 revision, will automatically reduce the percentage to 80%. So this allows for incredibly safe and controlled deployments. And maybe if anything goes wrong, you can instantly roll back traffic to previous stable revision. And that's how we can manage incoming traffic to our Cloud Run service agent. All right, so yep, that's a sneak peek on how you can manipulate the traffic management of your agent running on the Cloud Run. And now, changing, okay. And now for the next one, I would like to demonstrate how CloudTrace can integrate with your agent deployed on Cloud Run, especially when using an ADK. So this demo will show you how distributed tracing allows you to visualize the flow of requests through your agent, identifying bottlenecks and pinpoint exactly where an issue might be occurring within your agent's complex interactions, including LLM calls and tool uses. So I think it's invaluable for debugging and performance optimization. So let's start it. Okay, let's talk about observability. Knowing what's happening inside your AI agent, especially when it involves complex interactions with LLMs and external tools. So CloudTrace can provide invaluable insights for debugging and performance optimization. So for this demo, let's talk with our agent. So for example, in here, let's do a query and ask it about the weather. What is weather in New York? Like this. So as you can see that our agent produce some function call, execute the functions, and answer related to the information in New York, right? This request will generate trace data in a Google Cloud Trace. Now, let's go back to the Google Cloud Console and search Cloud Trace in here. Then let's go to this Trace Explorer. Okay, so this is the product details page of the Trace Explorer. And now you'll see several fields in the Trace Explorer and several span name entry field the name like agent run, the weather agent, our deployed agent name, and then call LLM and execute tool, get weather in this case. So let's click on one of these traces and dive into the details. So for example, let's click the agent run, and then let's see our latest tracing in here. And yeah, so this is the waterfall view, and it's incredibly powerful to know about the process of our agent. So a trace represents a complete end-to-end request as it flows through your system. So we can think it as a journey for a single user interaction with your agent, from the moment it hits our Cloud Run service agent until the response is sent back. So within each trace, you'll find multiple spans. Like in this example, we have invocation trace. Under it, we have agent run, call LLM, execute the tool, and call LLM back for the final response. So at the top, we see the overall duration of the request, encompassing everything from Cloud Run receiving the request to sending back the response. So this is often the root span for the entire request. And below that, we can see individual spans for different parts of our agent's execution. And for example, here's the span for the Cloud Run invocation itself. And crucially, because we are using the agent development kit, it already comes with built-in telemetry that automatically generates insightful spans. So this agent run, call LLM, and execute tool is already built in inside the ADK framework. So the agent run is the top level span, represents the entire execution of your AI agent's processing for that specific request, and encapsulating all its internal reasoning, tool calls, and LLM interactions. And under this, the call LLM. So whenever your agent interacts with the large language model, like Gemini, a call LLM span is created, showing precisely how long the model inference took, what is this LLM request, what is the LLM response, the session ID, and so on. And then when the agent decides to use one of its tools, it will invoke the execute tool tracing in here. So you can see the tool call arguments, the tool response, how long it took, and so on. So this granular visibility helps us pinpoint exactly where latency is introduced, diagnose any errors by seeing which step failed, and optimize our agent's performance by identifying slow operations. So it's an indispensable tool for any production AI agent. Okay, so yeah, as you can see before, I think robust observability with tools like CloudTrace is not just a nice to have, but it's an essential for confidently operating your AI agents in production. It helps you greatly to find the answers to those critical questions like why is my agent slow, or where did this error come from, and yeah, things like that. And for you that are interested to try the previous demo that is just showcased, deploying ADK agent to Cloud Run, load testing, managing traffics, and observe the tracing, you can visit the code lab here in this link. This code lab will contain step-by-step detailed instructions to replay all demo that is just shown, but this time by your own self. And then it will look like this. So here the code labs, what is the code labs look like? It provides you the introduction, the project preparation, how to build, the explanation of the backend script, deploying to Cloud Run, and the other things that showed in demo previously. Okay, and then, yep, the demo is end, but the question is it the end? Is it? I don't think so. So after discussing agent deployment options like ADK on Cloud Run and seeing some of its powerful features, we might thinking that, oh, great, that's it. We are ready for production. But the actual thing is, I myself not so sure, because this is just a beginning of understanding the full life cycle of deploying and managing AI agents in production environment. Okay, and the reality is, even with powerful platforms and great deployment tools, there are always the next challenges that emerge as your AI agent matures and its usage grows. So, what are some of these critical considerations that we need to keep in mind? So, I imagine that we will face the questions like this. Is my agent working properly when handling multiple users simultaneously? Or maybe what about the concurrency limit? For instance, how many concurrent requests can a single instance of my agent handle before performance degrades? And of course, finding this number and tuning this is very, very crucial for efficiency and cost. Or maybe the other question is, what is the rate limit on my LLM API calls? Are we bursting past our quota because our agent instance may be scaled out to 100 instance and our LLM API calls cannot handle it? And the other question is maybe how easy it is to debug when things go wrong in production. And frankly, there are many more of those kind of questions that will continuously occur. So these questions highlight the need for a robust deployment plan, continuous integration, continuous delivery and deployment, because we understand that deployment isn't a one-time event. It's a continuous process that requires ongoing attention to these operational aspects. So I will try to share my perspective and things that might be helpful for you in deploying your agent. So the first one, we these are some kind of example of critical architectural questions when planning for scalability. So the first is, if my agent scales to multiple instances, will my agent in each instance have same context? So this is about shared knowledge and consistency. If your agent relies on previous turns of conversation or maybe a user's profile, how do you ensure that context is available to any instance that picks up the request? And then the next question comes, if we already provide that, but the same user continuously chats and received by different agent instances, how do we handle the racing condition, right? So this is a classic distributed system problem, and particularly this is related to AI agent which supports conversation. What if two instances try to update the same user session data simultaneously? Should we deploy a distributed lock or things, any other things that ensure the sequence of user request is received and answered timely in sequence? And if the agent service containers scale to 20 instances, can my database resource handle all of those connections? So we also need to think about the downstream dependencies. Do they have sufficient resources to support the scalability of your agent services? So, yep, we need to carefully think about AI agent context or session management with the scalability in mind. This often means that using external or shared and highly scalable data stores, maybe for storing session, rather than relying on maybe simple database or in-memory state within the agent instance itself. And then also crucial reminder, yeah, we constantly hear this, but I want to emphasize this more in this case, always test your deployment. So my main principle is never doubt the deployed agent until proven otherwise. So we need to rigorously conduct integration tests to ensure all components of our architecture are working together seamlessly. We also need to perform load tests to understand how your agent performs under expected and unexpected peak traffic conditions. And of course, one of the most critical thing is conduct concurrency tests to see how it handle multiple simultaneous users and requests. So just because it works in development or maybe you deploy it with the initial number of user testing doesn't mean it will work well under real world production stress. So proactive testing will save us from reactive firefighting. And then once our agent in production, we cannot fly blindly, of course. We need to know what's happening, like what has been shown in previous demo. We need to prioritize observability. Usually, the typical cases I occurred is they just log something, printing something, but not really useful information is put into that log. So implement proper logging is very, very important. Ensure your agent emits meaningful logs at appropriate levels. Helping this will help you diagnose any issues and understand behavior. Don't just log errors, but log key events, inputs, and outputs too. And then enable request response tracing. As we already see with the demo, we can have thorough information about the delay, about the data in there. And I think it's very, very indispensable for troubleshooting performance bottlenecks or identifying where failure may occur. And then one of the important things is also we need to gain cost visibility, understand which parts of your agent's operation are incurring cost, particularly LLM calls. Maybe you provide too long context that doesn't really necessarily need to be used all. This will help you to optimize resource usage and manage your budget too. So without good observability, you won't have any confidence in deploying your agent. And then a reminder too from previous demo, employ a strategy where you gradually release new versions of your agent. So it's very, very dangerous if you go full power or big bang release to all of your user. So try to start deploying your new version, set traffic to 0%, and then gradually increase the traffic to the latest deployment, maybe 5%, 10%, inspect any metrics, repeat until you are very confident that the deployment is 100% safe. And crucially, if something happened, you can always easily roll back to the previous version. So gradual release strategy and rollback strategy, this is very, very important for you who want to deploy your agent to production. And don't forget to use text for versioning, because if you, it might not be verbose if you just use the revision ID for the cloud run, for example, right? It's easier if you use things like semantic versioning, version 1, version 1.1, and things like that. Okay, and finally, if all of this sounds like a lot of to take in, you need to prepare tracing, you need to prepare proper logging, proper pipeline, proper unit testing. I think it's worth to explore the agent starter pack in here. The agent starter pack available on GitHub is designed to help you go from idea to deployment faster. It provides several pre-built templates and tools to accelerate the development and deployment for production-ready agents on Google Cloud. So it incorporates many of the best practices we've discussed today and giving you a head start on building robust, scalable, and observable AI agents. And what it looks like. So you can go to this repository and it have some quick start for you, how to install the package, and then they have several templates of the agent like ADK Base, ADK Gemini Full Stack, and even LangGraph, Crew AI, and several other templates. Okay. All right. So okay. Then yeah, I hope this session has provided you with valuable insights into confidently deploying your AI agents later on. And yeah, thank you very much for your time and attention today. I give it back to Shai.
All right. Thank you so much, Alvin. That was a superb session. I especially loved the part with the spans for with the ADK happening automatically. It's something I spent a lot of time on in the past doing it manually. So I'll let you grab a glass of water. In the meantime, everyone, we're doing a quick pause, but we have some huge news for you dropping right now. So we have launched the Google for Startups Gemini Kit. This is brand new. You can check out the link. Think of it as your complete AI toolkit, giving you everything you need to start building and scaling with Gemini, from instant API access to cloud credits and on-demand learning resources, all in one place. We're also announcing new ways for you to get hands-on and connect in person with experts from the Gemini team. This week, we're kicking off Gemini API sprints events in Spain, and coming soon to Poland, the US, Israel, India, and Korea. These are immersive hands-on events where you will have the opportunity to get up to speed fast and learn how to quickly integrate Google AI and scale your business with support from experts from Gemini. And for top Series A founders in the community, we're presenting the Gemini Founders Forum, an event that will get founders together with the Gemini team in October for live talks and discussions on the future of AI. So it is all live right now, ready for you to explore. Just scan the QR code on the screen or type startup.google.com/Gemini. And I wanted to draw your attention also to the Google for Startups Cloud program. So as you embark on this exciting Gen AI learning journey with our experts, I'm certain that you'll want to try out the products and solutions you see used throughout. So if you're a startup, you can apply for cloud credits via our startup program and start building Gen AI solutions for your business right away. Credits cover both standard GCP operations, but also latest Gen AI features that you see in Startup School. We have various support offers for every different stage of startups, including tailored programs for AI first and Web3 companies. Scan the QR code or visit the link that just has been dropped to the chat to find out more. Credit amounts vary from $2,000 to even $250,000 based on the stage of your startup. And thank you so much for diving deep with us today. We've covered a tremendous amount of technical and strategic ground. I know that one of the biggest challenges after a session like this is taking this excitement and knowledge back to your teams and getting buy-in. So you need a simple, powerful, and visual way to share this vision and show them exactly where to start. That's why I'm excited to share the AI Agent Handbook. So this isn't just a recap of what we've discussed. It's a true strategic asset for you. It's beautifully designed, easily digestible guide that you can forward to your team leads with or your colleagues to spark their imagination. With 10 specific actionable use cases, it makes the potential of AI agents tangible for everyone, regardless of their role. Use it as your go-to resource to build momentum internally and start a real conversation about the implementation in your organization. The link to download should be in the chat right now, and you can also use the QR code or the link shown on screen. Consider it your first tool for driving adoption. We're getting there. So if you want to keep the conversation going before, during, or after class, join the AI Startup School Discord channel to connect with other founders like yourselves. Now, let's invite Alvin back to our virtual stage. We got a few burning questions from our audience.
Okay.
All right, let's see. 1 second. So we have a question. Do you run tests on the -- no traffic revision, or should this be done in a separate staging deployment?
Okay. Yeah. Thank you for the question. So this is an interesting question. So typically we will have our own development, staging, or production environment, right? And when we are talking about test in the air, particularly load testing, it's always best to do it in this, like you said, the staging or development deployment. But with notes that we need to ensure that the resource used in this kind of environment, for example, if you use two CPU on production or maybe 4 gigs of RAM in production, we also need to mirror it for the staging environment. This is to make sure that we will receive same behavior when we are doing load testing on those kind of deployment. And yeah, I'm not a fan to do load testing in production, obviously.
Okay, perfect. Um, so next question, if using data from our database, do we need to process this data to fit in a vector database for inference?
Okay, so this is depend on the use case. So using the database when we are talking about AI agent can have multiple functions, right? For example, in the demo, we show that we are using database to store our context, our conversation history, and things like that. But in the case of RAG, we use the database to retrieve the data to be used for grounded information, right? If your data is big and you are using this data for grounded inference, definitely you need to ensure that this data can be fit in your own database, in the vector database. But if you only use the database for storing session information, I don't think that you will need to modify this into a vector database or vector data, except if you want to utilize this session conversation data as a memory interaction. So in the memory setting, we try to keep the information of short-term memory and long-term memory. And in this kind of situation, you might also consider to change this session data into vector database too.
Okay, perfect. Last question. What best practices do you suggest for moving from collab prototypes to scalable deployments on Vertex AI?
Okay. So in my own experience, I think that it's always better to have a mindset where you are developing with CodeLab, you still kept the software engineering best practice there. Means that do not use naked code in there, use a proper function wrapping, use a proper modularization of your agent, of your tools. And then with those kind of settings, you can easily just copy paste the module or the function into the PyScript. Or maybe in some cases, you also can use a package that can help you migrate those kind of modules into a separate Python function as well. So it will be much easier compared to if you put each code lines into separate block without modularizing them. Yeah.
All right, perfect. That was such an awesome session, Alvin, and what a great way to wrap up Startup School Agentic. So, thank you so much for answering these questions and this amazing session. Really appreciate it. Um, yeah, and I think, yeah, we 1 second. I'll share the screen. Yeah, awesome. So we always want to hear from you what you think of these sessions to iterate and make sure the content is relevant to you. So please share your thoughts and feedback with us using the form here. Again, really appreciate you taking part in Startup School. Hope to see you for the next one, and also in the on-demand sessions if you get to catch them. Really appreciate it, and thank you so much. Oh, and closing remarks, final recap from me on what's up. You'll have access again to revisit the site until September to rewatch any of the classes on demand, and you'll have access to credits for 6 months from the redemption date. So thank you so much. Really appreciate it.